Hello and welcome to episode 11 in this series on Python natural language processing. In this video we're going to go over frequency distributions of words. So why would we want to do this? A frequency distribution of words can tell us how many times each word is used in a given text. Let's go ahead and look at some results and then see why this is valuable and gives us insight into text processing. So I've already imported NLTK. From NLTK I imported Word Tokenize, which we've seen in previous videos, and Wikipedia as wiki, so we can get some text to grab from. Now the next step here, we'll still be using the NLTK, the Natural Language Processing Toolkit, and we're going to import FreqDist, which is frequency distribution. So this is how we do that. We go from NLTK dot probability. Is that right? Yes, I believe so. Imports capital F REQ dist DIST for frequency distribution. Okay, we got it. So we've done this before, so I'll go over this quickly. We need to grab the text and then tokenize it, because when we grab the text it's a long string and we need to split it up into words. So let's go ahead and look up camera. Camera equals wiki.summary and the literal string of camera. Okay. And I'm just going to reuse that variable name for simplicity here. Camera equals word tokenize camera. So that's the string we're tokenizing. Alright, so now we're treading into the new territory of the frequency distribution. So we can go we'll go FreqDist underbar camera equals. We're going to assign it what we imported, so that's FreqDist, and pass it camera. Alright, so let's see what this returns. It gives us a frequency distribution, and we can see that camera was used 7 times, period was used 7, the and the 6 respectively, of, or. So we can get a sense of the most common words used in the text. Now what's nice about frequency distribution here is it returns them in order. So notice we're descending from 7 to 6 to 5 to 4. Now, the last video we talked about stop words. An interesting observation here is the most common words are stop words. These are the words that glue sentences together in written and spoken word, but don't give us a lot of value if we're looking for, or if we were analyzing text. The isn't going to tell us anything about the camera. Of is not going to tell us anything about a camera. However, images is closer, and camera is the most frequent. So that can give us an idea. Well, actually, that's not really true, because here's a good point to bring up. Now notice that the and the appear 6 times each. So it doesn't take a rocket science to see that if we add 6 and 6 together we get 12. So actually the most common word here is the. And there's probably other cases where of the stop words, for example, might be uppercase and aren't counted in a word count. So this frequency distribution is a good start, but we should build upon it in order to create a more robust frequency distribution, so that we account for upper and lower case. So long story short, This is a nice built-in function that NLTK offers. It does the counting for us, but we can refine it to get it to give us a more accurate distribution of words that we're looking for. So perhaps in this frequency distribution, we don't want to remove stop words, but we want to get a good idea of the most popular words in this article. And a good way to do that would be to convert all. If the word has an uppercase letter as the first one, we would want to make it lowercase. Okay, moving on. So we'll set all that aside now, and we'll just use the frequency distribution method unaltered. Now I'd like to show you an example of something. We'll look at an article that's completely independent of camera. So what is a camera? A camera is a piece of technology. It takes images. It's a thing. It's a tool that people use. Let's look at something completely different. Let's look up an animal. Let's look up bird. Bird. And we'll see why this is interesting in a second. So wiki.summary bird, and bird equals word tokenize bird. I think I got the spellings correct. Now let's take the frequency distribution of our tokenized list. So I'll change this to bird, and I'll pass it bird. And let's see what it returns. Okay, we get punctuation as the most popular, then the. Now notice that's the most popular word in camera, and of our birds, which is the topic, species, which is unique, in two. That's pretty interesting. So even though they're not all the same stop words, notice that these two independent articles, the most frequent words are considered to be stop words. Of, is there, the, is there. Let's do one more article. So what is independent from a camera and an animal? Well, let's look up language. So this is an abstract category of things, of a type of thing that we're studying actually. Language equals wiki. You know the drill. We'll do wiki.summary. Language. And we'll do language equals word tokenize and language. Okay, and we'll do the frequency distribution of language. Oh, that's funny. Well, this is actually good that this mistake happened. So this is the reason specifically why we need to tokenize the words, because we can take a frequency distribution of the string when it's not separated by word, and what do we get? We get the most we get the frequency distribution of letters. And what's funny about this is I pass frequency distribution a string, a literal string of language, so that gives us a letter count. So A, G are the most common in language because they appear twice. So although that's humorous, that's not what we're looking for. I'm looking for the variable language, which is our tokenized list of words. Huh. Language. Well, what am I missing here? Word tokenized language. this. Yep. Alright, let's see. What am I missing? We got the Wikipedia summary. I'll follow the pattern one more time. So language equals Wikipedia summary language. Oh. Yeah. And then I want to do, I'll just do lang equals wiki, or word tokenize. And then I want to pass it language. So then let's just see what it is. Okay. So we're getting closer. And then I'm going to go FreqDist lang. Okay, there we go. I'm not sure why that happened in the other case. Perhaps you know why. Okay, so what are we seeing here? We see and, the, of, language, the topic of the article, to, language. Oh, here languages with an S and language are both counted. So that's 16 plus 15, which gives us the illusion that these are two separate words, but they are actually referencing the same thing. In is. So why do we care about this? Well, these are three uncorrelated things. We looked up bird, we looked up camera, and we looked up language. And notice the most frequent words are these stop words. Why is this interesting? Well, it's not exactly apparent if you weren't thinking about it in terms of a frequency distribution that most of our language, when we're speaking and writing, is comprised of these words that glue our abstractions or ideas together, or perhaps descriptions. So when we actually analyze these words, we see that independent of the topic, stop words are the most frequent. And they are a common across categories. There's some interesting theory behind this, and we'll explore that in other videos. But this video served to show you that across categories, we get stop words being the most common. And then following that, it seems like, at least at Wikipedia, what we've gained from this is perhaps we could scan through Wikipedia articles. And if we wanted to determine without knowing what the article was about, we could see that the most frequent word, or a frequent word at the higher end of that, is the article title. Because notice in camera, well, it's not the most frequent word we know because of uppercase and lowercase the, but it's pretty high up there. And language, let's see where it goes. So languages and languages. So even though that's not a groundbreaking revelation that the subject of the article is a frequently used word, it's a starting point if we wanted to perhaps crawl through articles to determine the meaning, is that a frequently used word is going to be that subject of the article. Now the computer doesn't know that, so we'd have to teach it that. And that's a starting point to understand text that we pass in that we don't already know what the topic is. So let's wrap this up. In conclusion, what we learned here is that the most frequent words are stop words. And this can be extremely useful because we want to cut those out in most cases to reduce our data set. So thank you for watching this video on frequency distributions. Stay tuned for more content and have a great day.